So let's go ahead and start the webinar. I'm Joshua Fontana from Boundary Systems. Today we're gonna be going over what's new in Sheetmetal Design in Creo 4. This is going to be a relatively short webinar. There's not a lot of subject matter in this topic, so we'll just go ahead and get into that. So as far as the agenda here, we'll do a short introduction of Boundary Systems. We'll also do an introduction of what's new in Sheetmetal Design, and then I'll also do a demonstration. Then afterwards, we'll leave some time for some questions if you have any questions. Okay, about Boundary Systems. We are a tech leader based out of Cleveland, whose partners include PTC, Solid Thinking, eTraj, ZW and ZWCAD, and other tech companies. So we are the number 16th fastest growing private company in the Cleveland area also. So some of our capabilities include product lifecycle management, data management, CAD design and consulting, simulation also, and product development. So we can handle a lot of your project needs. This is just over here on the right is just a list of some of the companies that we work with. Okay, so some of our accolades include some industrial awards from the Inc. 5000 and the Weatherhead 100, and some other major accreditations including the Windchill Certified Implementer. We're also a PTC Preferred Service Provider and a certified training partner, so we can handle all your training needs also. Okay, so some of the software solutions we offer from PTC, of course, that's what we're talking about today. We're talking about Creo Parametric 4.0, but we also utilize Solid Thinking products, eTraj, and ZWCAD. So if you're interested in any of those products, feel free to reach out to us. Okay, and again, my name's Joshua Fontana. There's my email address there, so if you have any questions at any point, feel free to toss me an email. If you have more sales-related questions about how much things cost, how much projects would cost, and things of that nature, you can contact Mike Kotloski with his email address there below also. Okay, so we'll get into the sheet metal portion of it. So I have a few slides here before I do the demonstration. So one of the new things in sheet metal is the ability to create these twist walls. So it's a new feature that you can utilize to create the spiraling sheet metal effect. Okay, so of course you can define the length and the width of the wall and the amount of rotation. Okay, so the rotation is about a reference, which is an axis in this case, and the axis can actually be manipulated and moved to different locations. So it does need to reference something, and you see here in these figures that there is in figure 3, there's a datum point that axis can actually go through to reference to move its location. Oh, and one of the other options, as you see there, is the end wall width. So the wall width at the beginning of the bend or the twist, where you're selecting an edge for reference for placement, can be different than the other end. So you can control the width at both sides. And that's depicted also in figure 3. Okay, next is the ability to utilize dependency controls with your punch and die forms. So now you can control whether you want your die forms to update, or I'm sorry, your actual, your forms to update if your dies change. So you have the ability to manipulate your dies and have only some of your forms to regenerate and update automatically. So that's your three options. So you have automatic update. So if you change your dies, then your forms will change whenever they regenerate. Then you have a manual update. So the manual update, you have to actually go back into the form and then edit definition it and then do that manually. And then no dependency will allow you to update the actual die, and then it will not update the actual form. And there's no way to update that after that. So if you make it not dependent, then it is permanent. You can't have it update. You just have to get rid of the feature and reapply it with the die. Okay, the next feature here is creating edge bends. So you could create edge bends back in Creo 3, but really the new thing here is the ability to manipulate them a bit more. So as we see there in figure 3, that it's actually creating a relief after you create that edge bend. So that's really the new part here. There's a full list of the relief types whenever you're creating these. Okay, so the other things you can do with these edge bends is create individual sets. So you can have different radiuses associated with different edge sets. It's much like the chamfer tool or the round tool in Creo Parametric. You can have round sets and chamfer sets, have different dimensioning schemes associated with each set. Okay. So the other thing is, see in figure 2, is you can create partial edge bends. So it don't have to go down the entire edge. You can control the length of the bend with either the drag handle, as you see in figure 1, which is the white box at the end of the actual edges, or with dimensional values. Okay, the next new thing here is the ability to close the corners of your bends where they come together. Okay, so that's a edge treatment. As you see there in figure 2 is the default where it leaves a gap actually. Okay, so that may be undesirable in some cases, and it may not be realistic in your manufacturing process. So now we have the ability, we see there in figure 1, there's a checkbox down at the bottom of the edge treatment tab, and it allows you to close those corners together. Okay. So, and the next thing, and I think this is a really nice feature, and I've kind of been waiting for this, is the ability to use flexible modeling in sheet metal. Okay, so now whenever you have a sheet metal part, you have a flexible modeling tab in there also. So this tab is much like the flexible modeling tab whenever you're doing standard solid part design, where you have the ability to move and offset faces and etc. But now there's specific sheet metal functionality in there also. Like you can pull on a wall, edit bends rapidly also. Okay. So the real power here is the ability to do this with imported models, of course, and legacy models. So then you can easily manipulate some of those the models with flexible modeling. So the other use case, just like in standard part mode, is that you can use flexible modeling for late stage design changes. So maybe the project is just about done and you need to tweak it a little bit to suffice the needs of your design intent. So rather than going back into the actual the model and trying to figure out how the designer built up the model, you can just utilize flexible modeling to manipulate your design. The other use case that's quite good, I do believe, is if you have designers that have a lack of design intent built into the model, okay? So there's a chance that if you go ahead and update something, it's not going to update in a predictable manner. So then you can kind of get around that by utilizing flexible modeling. Okay. Okay, so I'll go ahead and do the demo portion of the webinar. Let me get rid of these slides and open up some software. So here I have Creo Parametric 4.0. And what we're going to do is, in this part, is just create a twist wall, okay? So we have, this is a sheet metal part. So we go to the model tab shapes group and go ahead and create a twist. So then it's asking us for reference, and of course, just like many sheet metal features, you can select an edge, and then it creates your wall. So here again, we can control the actual rotation of our wall and the length of our wall with the drag handles or dimensional values. Okay, so in this case, we'll give it a nice even 90 degrees and or 90 length. Yeah, this needs to be 90 degrees. The length needs to be 75 units. Okay. So again, you can play around with this a little bit and create quite a bit of twist in here if you want to. So that's kind of fun. So the other thing you do with these twist walls is, again, you can manipulate the width at the beginning and the width at the end. So that's what these are over here. So here we have the ability to have a dimension associated with an offset for this edge. The same thing can happen on the other side. So now we have a dimensional value associated with that. So you're probably wondering if I can actually drag this drag handle out beyond the edge to create an overhang. And yes, you can. So you can just go ahead and drag it out here, or swap the value for the actual dimensions. Okay, so we'll go ahead and create another wall on this side, a twist. And again, an edge reference. And this time we are going to go ahead and create a smaller feature that's equal on both sides. So now whenever I manipulate this dimension, it's equal on both sides of the axes. Okay. But maybe the axis location is not desirable for our design intent. So by default, it puts it at the middle of the selected placement edge. So we can actually move that by selecting another reference. So here's a datum point. Now it'll move the location of that axis. So now we can manipulate the location, the length, the amount of twist, the width at this end, but we would also like to manipulate the width at the other end. So then we have another icon up here to modify the wall end. So then we can give this a different dimensional value than this 12.7 unit value. So that's how you can create twist walls in Creo now. So the next part here we'll go over is the dependency for your dies and forms. So here we have a piece of sheet metal here already that has a bunch of forms built into it. So what we're going to do is go ahead and check out some of these forms. So in this case, this form here, we see it set up to be automatic in the Shapes tab. Okay. So what we can do is open up the base model and manipulate the design. So we'll go ahead and select a feature to manipulate. And in this case, we'll change this reference edge here, or this construction line, to 28 units. So it changes the entire die. Okay. So if we go back to our part and regenerate, then we see that it does update in this location automatically. So these other locations, they did not. So we'll go ahead and select those locations and see how they're being controlled. So if we go again to the Shapes tab, see it's manually being updated. So that means we have to do that. It's not going to do it all by itself. So manual is a good place. So if you don't want it to update automatically, but you want the option to have it update, then manual is your sweet spot. Okay. So then if that is desirable to update, then you can change it to automatic. All your geometry updates accordingly. So the other option here, as we see with this other form, is to not have it update. So we have no dependency checked here. So then I don't have the ability to actually change this. So again, there's pros and cons there. So I can't actually change one of the radial buttons here to have it update, unlike the manual. So it depends on your design intent. Okay, so that's the updates for sheet metal dependency as far as die forms. Okay, so next is edge bends. So we'll go ahead and create some edge bends on this part. So we'll go to the bend drop down and select edge bend, and then we can select our multiple edges utilizing the control key. We see it gives us our default value, which is the thickness for the radius. Okay, so that might be undesirable to have in multiple locations, but I don't want to have two edge bend features either. So now we have the ability to actually remove some of these selected edges and create a new set. So now this can be a specific value all by itself. Oh, that's a bit big. There we go. Okay, so some of the other options with the edge bend, excuse me, is the ability to control the actual length of the bend. So maybe you don't want to have it bend all the way down. Then again, you can utilize the drag handle or the dimensional values. So another option associated with your bends is that, and specifically in this location, we can actually create some relief here. So maybe this isn't a realistic scenario that can be manufactured. So we can actually create a relief in this location. So by default, it gives it a rip, just like in many of the other defaults. But we have the full list of reliefs here. So if we'd like a stretched relief, so that's a little more realistic. A rectangular relief. And then an obround. And then we can change this to tangent to bend. And that should work. There we go. So now there's our all-brown relief there. Okay, so next what we have is we have here a relatively finished part, or it may be finished, but we need to make some design changes. So what we could do is, instead of utilizing our standard edit definition and so on to manipulate, we can use flexible modeling. So we go to the flexible modeling tab, and we see there's a lot of the standard flexible modeling tools. Okay, so our move, offset, pattern, symmetry, also in remove. But there's also sheet metal specific tools. Okay, so maybe in this case we would like to manipulate this part by moving these tabs out a little bit. We don't have enough clearance in here for our objective. So what we can do is just simply pull this wall out. So we can select our references here and just drag it out. And it knows to extend these other faces and move these bends also. So we have a dimensional value here associated with the before and after placement. So maybe we only really need to juke this out a half a unit to add some extra clearance in here. And then, much like in the solid modeling freestyle, we do have this pull wall stacked up in our model tree. So if that was undesirable at any point, we could always go back and delete it and it goes back to its original position. Okay, so let's go ahead and do that with a couple more features, and then we'll edit some bends and use some other features. So again, we'll come up here to this location and we'll select both of these surfaces. So, and then pull these upward. Notice since this round isn't in the way of the other material, it gets rid of that relief for us. So that might be desirable. But maybe the angle of these bends is undesirable now. They don't meet our design intent anymore. So we can go and edit the bend also. So now this wall is at a different angle. So the other thing, very much like in the standard modeling, flexible modeling tool, is that we can offset surfaces. So maybe the length of this wall is undesirable now. So we can just drag it outward. And again, all of these manipulations are being stacked up here in the model tree. So those are some of the manipulation tools that you can utilize in flexible modeling with your sheet metal part. Okay, so that concludes the demonstration. Feel free to check out the Boundary Systems website to register for more webinars. And we also have hands-on workshops in the mix also. If you go to the events tab up at the top of the website, then we have free events all the time. If you guys have any questions, feel free to type them into the chat box in your GoToWebinar dialog. And again, my name is Joshua Fontana. You can also email me at my email as seen below. So I'll wait a couple minutes to see if there's some questions. We do have a question. So one of the questions is on the twist, is the twist always symmetric about the axes? So yeah, it is. You can move the axes, but yeah, it is symmetric about the axes. In your twist wall. And then there's another question here about the updating of your forms. So the question is, once your manual form has been updated, once updated, can it go back to manual? So if you change it from manual to automatic, so it does update, can I go back to manual? And that question is no. So once it's updated, it can't revert back to what it was before. And I can actually show you that. Let me see if I still have that open. That's the actual form. Actually, this one's been modified. Let me open this up again. Update control. Okay, so we know this location is set to manual. So we can go ahead and edit definition in that location again and then see what happens. Let me get rid of this so it's not failing on us. So if we change it from manual to automatic, so it does update. Okay, so we'll go ahead and do that again. Okay. Oh, well, we didn't change the actual geometry for our die. Just cancel this. And go back and change that die. I think that was 28 units. It looks like it regenerated, so it should be fine. We'll regenerate this. And this does update. Again, do the same thing over here. Okay, so right now it does not update. If we change it so it does update, okay, so now it looks the same as that one. If I change it to manual, we see that it does not go back to its reverted form. If we hit accept, then it stays the same as the updated form. So it can't go back and forth like that. Okay, good. Is there any more questions? Let's see, I'll wait a little bit longer, see if we get some more questions coming in. Okay, so we'll go ahead and conclude the webinar. Again, if you guys have any questions, feel free to contact me or the sales guy if you have sales related questions, so we can help you out there. Okay, thank you for your time and have a good day.